Hi everyone. In this lesson we're going to go over the nth root test. Now, like the ratio test, the nth root test is another test that we can use to determine if a series converges or diverges. And you'll notice that the nth root test looks exactly the same as the ratio test, except the quantity inside the limit takes a different form. So the nth root test makes this statement. We start out with a series, and we evaluate the limit as n goes to infinity of the nth root of the absolute value of the terms in the series a sub n. We can also write it like this, of course. That's another way of writing the nth root of the absolute value. And we let this quantity equal the value rho, just like for the ratio test. Then the results that we have down here are exactly the same as the ratio test. If the rho is less than 1, then the series converges absolutely, meaning that the original series converges as well as the series of the absolute values. That's a little stronger than just saying the series itself converges. On the other hand, if rho is larger than 1, or rho is equal to infinity, then the series diverges. And if rho equals 1, well, once again, the test fails, meaning that the series may converge or it may diverge. You need to use another test to determine which. So you notice that these three cases are exactly the same as the ratio test. Now let's take a look at a few examples that illustrate how we use the nth root test. And before we look at those examples, take note of one thing. This is an important limit that you'll oftentimes run across when using the nth root test. The limit as n goes to infinity of n to the 1 over n power, or the nth root of n, is equal to 1. Okay, that's something that we can prove using L'Hopital's rule. So as we do examples down here, just keep in mind this limit. So that's the nth root of n, or as we have written down here, that's equal to 1. And once again, you can prove this using L'Hopital's rule. Notice that this limit is of the form infinity to the 0 power. Okay, notice as n goes to infinity, your base goes to infinity, the exponent goes to 0. So this is an indeterminate form, and you can use L'Hopital's rule to prove this result. Okay, now let's take a look at a few examples. So in our first example here, we want to determine if the sum from 1 to infinity of n divided by 2 to the nth power converges or diverges using the root test. So we have to evaluate the limit Now in this case, the ANs are just n over 2 to the nth power, so this is going to be and now by rules of exponents, right, we just use the fact that a over b to the c power is a to the c power divided by b to the c power, right? So that's the rule that we used going from here to here. And now, of course, we can use the other exponent rule that the denominator here is just going to be 2. It's going to be 2 raised to the n times 1 over n power. N times 1 over n is just 1. So we get like that. And now, using the result that we just mentioned, this limit right here is approaching 1 as n goes to infinity. And so we end up with this equaling 1/2. That's our rho. And since that is less than 1, we have convergence by the nth root test. Technically, we have absolute convergence, but we don't really need to worry about that because all these terms are positive anyway. So that's how you apply the nth root test. Let's take a look at a few more examples. So in this example, we want to determine if the sum from 1 to infinity of 3 to the nth power divided by n to the 6th power converges or diverges using the root test. So once again, we want to consider and in this case, that's going to be and we can simplify this using rules of exponents. Now notice that the numerator is just going to become 3. It's going to be 3 to the n raised to the 1 over n power. Multiply those exponents, you get 3. And in the denominator, let's see, you're going to get n to the 6th raised to the 1 over n power. Now we can actually write that as, right, if we multiply those exponents together. And let's also note that we can write that like this. Okay. So really, we just interchanged the exponents here. You're allowed to do that. So we can write the denominator here as like that. Now once again, as n goes to infinity, we're going to use that result that the nth root of n, this is approaching 1, and 1 to the 6th power is just 1, of course, so our limit turns out to be 3 over 1, right? That's 1 to the 6th, which is just 1, and this is our row. And since the row is larger than 1 in this case, we have divergence, so this series diverges by case 2 of the nth root test since the row is larger than 1. Now take note with this example, as with the previous example, you could have actually used the ratio test and you would end up with the same result, that the series diverges, right? If you had looked at the limit as n goes to infinity of all right, now this is applying the ratio test here. So you're going to get, now notice that 3 to the n plus 1 over 3 to the n, that'll give us 3. And then we're going to have, if we flip this up, we're going to have n to the 6th divided by n plus 1 to the 6th power. And now this quantity, since the denominator is a polynomial of degree 6 with a coefficient of 1, its leading term is n to the 6th. This quantity right here is going to 1. This is approaching 1, and so we get a limit of 3. And so by the ratio test, we also get rho equals 3. And so we get divergence by the ratio test as well. Let's take a look at another example. Now in this problem, we want to determine if this series converges or diverges. So once again, we'll apply the root test. So there we go. Now, simplifying this, multiply these exponents together. N times 1 over n will just give you 1 again. And so you'll get And this limit, of course, this quantity here goes to 0. And so we end up with 1. Oh, so we see here that the test fails. Okay, so what we have to do is, that's it. We have to try to use some other test to determine if this series converges or diverges. Well, if we look at the an terms here, let's take note of something here. If we look at the limit n goes to infinity of those an terms, you should recognize that this is a common limit that we've run across before. This limit is going to equal e to the negative third power, right? Okay, remember that result from previous discussions of L'Hopital's rule, and then we ran across it previously when we were studying series. Now e to the negative third, of course, does not equal 0. So the limit of the an terms here does not equal 0. So therefore that series diverges by the nth term test. And that's it. So we've determined that this series diverges. We tried to use the root test, but it didn't work. So we had to try to use some other test. In this case, the nth term test was the appropriate one to use, and we see that this series diverges. And that concludes this discussion about the nth root test with a few examples.